I'm really happy to announce Liat Yosef. He is a front-end architect at Duda company, and he will tell us about microscopes and about how to build a modular React app in a bundled world. So, ladies and gentlemen, Liat Yosef in front of us. Hello, Liat. How are you?
Hi, Tommy. Good morning. How are you?
Good
And hi
morning.
to everyone listening. I hope it will be an amazing second day of the conference. Last day I watched and it was awesome. And I'm very honored to be here and start the second day.
Yes, it's a huge pleasure to meet you. I was waiting for your presentation. So, yes, the scene is yours. Let me just share your presentation, and yep, microphone is yours. Thank you.
Thank you, Tommy. Yes. Hi, everyone. So, as Tommy mentioned, the title of my presentation is Microscopes. And I thought that it would be best to start the second day of this amazing React conference in talking something about more high-level concept of how to build a modular app when everything is bundled. It's so funny today that we invest so much in breaking our code into small components, reusable components, and we try to optimize the imports and architect our code in the most in the best way, in the most convenient way. But then we just bundle everything and we send it to the client as one giant JS bundle. So I'm going to overview some methods to avoid that or some ideas on how to tackle that. And let's begin. So this image is not related to React, that is the pillars of creation. That's a beautiful picture taken from the Hubble telescope. And that's 7,000 light years away. And without the Hubble telescope, we wouldn't be able to see things that are so remote, that are so far away. And if we look at the Hubble, it was launched in 1990, and it cost $4.7 billion to build and to launch. It was delayed several times, and it was a huge endeavor. I think it's one of the most complex scientific achievements of the humankind, launching a space telescope into space where it can observe everything in the deep space and to watch it. But there was one problem. Few weeks after it launched, the images that we got from Hubble were so blurred, were in such bad resolution that we couldn't make anything of them. So obviously we didn't launch $5 billion telescope just to get blurry images, right? So if you do it in your camera, you would have this notification, your lenses are dirty, please clear your lenses, but you can't really do it in a space telescope. So they had to build a mission that took 3 years to practice in order to send astronauts to the Hubble telescope and fix it. So just imagine you launch something to outer space and it's so complex that if something small is getting broken, something small is getting out of hand, you have to build a specific space mission for 3 years, train people just to send it out there and fix it. And if you think of our code today, if you build a huge monolith, that's something similar, right? You have something in production, and if something breaks, you have to work very, very hard in order to fix it without breaking other things. Today, in space, we have several companies. One of them is Planet Labs, that actually launches what's called a constellation of satellites. So instead of one big telescope, one huge satellite, they launch hundreds or thousands of mini satellites that just circle the Earth. And every one of them is taking a small picture, a little picture. Every one of them is handling its own domain. And then eventually you combine all of those images together and you get an image. And the best thing about it is that if one of them is getting broken, one of them is bad, you just launch another one, right? It's a satellite that costs, I think, like a couple of hundred, maybe 100,000 or a couple of tens of $1,000 to launch. So you just decommission one and launch another one. And that's the kind of architecture that we want in our code. We want separate components, separate services, that if something breaks, we can just launch another one. So a little bit about myself. My name is Liad Yosef. I'm the client architect in Duda. I'm a web enthusiast, and starting lately, I'm also a metaverse enthusiast. But today we're going to talk about the web, and the lecture would be about bundled world above and beyond. So like I said, how can we handle bundling on one hand, so we don't ship to the browser hundreds or even thousands of files, but on the other hand, keep our applications disconnected, keep our applications with independent parts that we can later fix or deploy or build separately, independently, if we'd like. So the first question that you ask yourself is why? Why do we even bundle? Why do we need to bundle code, right? So let's look back. Let's look at front-end code bases before the invention of bundling tools. It was a wild west of dinosaurs. Yeah, I'm mixing metaphors and images here, but it was a wild west of dinosaurs, and the code was like huge files, a lot of them, a lot of files that you would just send to the client, sent to the browser, one after the other, and you had to take care of the order of the files, and you have to take care that no file is declaring a variable that is overriding or overshadowing another file, and it's not. I mean, that's not the way that we want to build our software, right? It's not a scalable way. It worked for several years, but as our programs, as our applications became more complex, we can't really rely on this brittle method in order to send send our files to the client. So we came up with imports, ES6 imports. I'm sure everyone here knows. It's for a few years. That's a standard now, especially in client code. In Node, it became standard about a year ago or so with ES modules. But when we write code, if we have an application that uses several other parts, then we just import them, right? We have the up wrapper that exports a function, the topper, and the button that exports a function, and we just import them in our app. So what happens if those parts also need to import other parts? For example, maybe our app wrapper need to import something that's called expandable and label, and the top bar need to import label as well. So what we're starting to see here is that when we use imports, we actually define what's called a dependency graph. We define parts that are importing other parts, and there might be multiple dependencies or cyclical dependencies. So it's very important to know that this kind of structure that we impose on our application, it imposes a very complex graph that someone needs to deal with. Someone needs to know, okay, who is importing what, and how do I provide this thing to where it's needed. So we have a tool today, which is the standard. It's called Webpack, and I have a little asterisk here because if I'd waited another month to do this presentation, maybe it would be something else, like ESBuild, Vite, Rollup, SWC, ROM. We have a lot of contenders to the title of the standard build tool, but today the de facto standard is Webpack. And Webpack actually takes all of these assets, all of these files, all of these parts of our application, and try to bundle them to a single or multiple JavaScript files and assets. So what happens is that where you have parts that import other parts, Webpack knows how to interpret this tree. Let's see how it does it. So like we said, it creates a single file with the entire app's code, and it's really easy to configure. You just point it to the entry file, right? So it says, okay, I want to start from this file and then try to understand what is the graph, what is the import chain from this file, and then from it try to create the bundle. Okay, so it's like it's here. Let's say I want to build the Avengers app. So I have the Avengers that import Iron Man and Hulk, right? And Iron Man is maybe some sort of a common JS file, so not ES modules, but common JS, and Hulk is another file, and they in turn import CSS files and maybe an NPM package or maybe a utility package, and all of this is important. And the NPM package, like we know, NPM packages like company, so they like to import more and more NPM packages. So we have this dependency graph, and Webpack should handle all of this graph, and what it does is just bundles it, right? So it takes everything, it builds this graph, and just puts it all into a single file, a single asset that you can later put wherever you want. You can put it on CDN, and it looks like that, right? If you ever looked in a Webpack output, it's just a single file a single array that knows to handle all of these connections. And then this file can be used in a script tag. So instead of 20 script tags, we can now have just the one bundle script tag. But now we have a problem because we didn't get rid of all the complexity of the app. We just put it in the same file. Like when you're cleaning your house and just put it in the same drawer, you still have the mess just in your drawer. And sometimes bundles can be very, very big if you're not controlling the bundles. And by the way, Webpack 4 and Webpack 5 have a little bit more of automatic control on the bundles. But if you're not trying to do something active in order to control your bundles, they can become very large very quickly. Yeah. Okay. What can we do with it? So in Webpack, and it's not there in other tools, but it will be in the future, we can define code splits. And code splits in our code, they're just like points where we tell Webpack, okay, from here, I want you to build another bundle or chunk, as it is called. So for example, I can decide that you see like the yellow files here are related to one area of the code, and the red files are related to other area, etc., etc. So I want Webpack to bundle them in different files, and I want maybe the green part is my entry point, and I want the entry point to be loaded first, and only if the red part is needed, it will load the red file. This is called a split point, and easy way to do that is just define dynamic imports. So you can see in the first line, we have a static import, which is import something from something. Then Webpack will automatically include Iron Man in the current chunk because it says, okay, this is synchronous import. I want this content to be available immediately. But if we use require as a function or import as a function, if we use the import as a function, require as a function is still a static import, don't get confused. If we use import as a function, then when we put the await keyword before it, we actually signal Webpack, okay, I can wait for you to download this chunk, meaning that the content in Hulk.js doesn't have to be bundled in the same chunk that I'm in. I can wait for you to get it from me. Okay, so Webpack knows that it can create a code split. It can create what we call a dynamic chunk there, and then doesn't have to be bundled in the same bundle. And we can do it. We can take it to the extreme, right? This is an example of code that we have in our code, and we have some sort of like an app manager that actually creates a lot of dynamic imports for all of our apps, and every one of them is being bundled in a different chunk. So in that way, we already achieve like some sort of separation, because even though it's the same Webpack and it's the same build and everything, still we can do the dynamic import part. We can tell the browser, okay, don't load, for example, my content editor until the user does something. Okay, and this is very easy to define in Webpack. This is how it looks in real life. Instead of a huge bundle like we saw that contains all the parts of your application, you have separate bundles, and you have Webpack as the orchestrator that knows that from this point in the code, I would load the dynamic chunk or other chunk if something happens. Okay, so this is one good way to do chunking. And when we use React, we can actually leverage that. So the React team gave us something really cool that's called lazy and suspense. Because let's stop for a second and think and remember how a React app behaves. So if you have a React application or React component and you want to use other components within it, these components has to be available to React the moment that you use them, right? So if you have, like we saw earlier, we have the app and we have the topper and maybe the left panel. So when we render the app, the topper and the left panel has to be there. Now, if we work with dynamic chunk loading, this is like a small problem, because Webpack doesn't know that React needs these topper and left panel immediately. If we try to load them dynamically, React will throw an error, and rightfully so. It will say, okay, you put a top bar here, but I still don't have the code for it. I don't know what to do. I don't know, should I stop the rendering? Should I continue? So the React team gave us suspense and lazy about 2 or something years ago. And that's a really good way to tell React, okay, wait for a component to be available maybe via dynamic chunk loading, and only then present it. Okay, so I imagine everyone here knows it, but for example, if I have the solar system and I want to render Earth immediately, but I want to render Mars only if Elon Musk is present, right? Because he's the one that's going to get us to Mars. So just see that what I'm doing here, I can declare Mars not as a React component, but as a lazy call to a dynamic chunk, in this case, a promise, the import promise. Okay, so what this code means, what this code tells React, it tells React, and these lines specifically, it tells React, Mars is not a component. Mars is like a waiting statement. It's a promise. So if you want to try to render Mars, you have to wait for something to happen in order to render it. And then React would say, and rightfully so, okay, what should I render instead? And if you try to use it like that, just with lazy, React will still throw an error, because it will say, okay, it's nice of you to tell me that I need to wait for Mars to be present, but I still don't know what to render there. And then we have the suspense, which is completing it. And suspense basically means you can see that I wrapped the lazy part, the Elon Musk and Mars, I wrapped it in suspense. And suspense basically means to React, tells React, okay, when you get to this part, if it's not present, display something else. Okay, so suspense is like the fallback or the catch clause in a try catch, which is React. So here we define the fallback as a spinner. And what the spinner basically means is that until Mars will be present, there will be a spinner there. So Earth will be rendered immediately. And when React would get to Mars, it would go and try to fetch the code of Mars. And it will take a few seconds or milliseconds, depending on the network. And only then, only when it's present, it would render Mars. And this is super awesome, and this is super cool, and that's something that everyone can use right now. And I would say, suspense can be in any level, so it doesn't have to surround only the part which is lazy. It can surround whatever you want, and then just take into account that in that way of writing, there will be a spinner on all of our app until Mars will be present. So even Earth won't be presented until Mars will be present, and only then both of them will be presented, which is really cool, and you can use it in the browser today. In React 18, they released a support for SSR suspense, so doing a suspense on the server side. As you can imagine, if you're doing server-side rendering with suspense, it's much more complicated, because the server-side renders something and then sends it to the client, and you don't get a supplementary from the server, right? So the server can't wait for something. But now in React SSR, it can wait, and that's super interesting. And I urge any of you who is interested in SSR or server-side rendering to check out SSR suspense. Dan Abramov wrote a nice post on it. But we'll go back, we'll return to our talk right now. So we ran into the problem of how do we support more than one screen, or for example, how do we support if we have different parts of our app. For example, you can see here the dashboard, what we call the dashboard, and we have the editor, and we have maybe the main site. How do we do it? How do we build all of it in the same code base, or should it be the same code base in the same build? That's a question that I think everyone who's writing a mid to large app will run into it at some point. How do I split my code? How do I build my code in an efficient way? So let's take an example here. Let's say that I have three screens or three entry points for my user that I want to present, and I want to do some sort of a router, right? So I'm saying, okay, this is my app, and I'm lazy importing. You remember lazy importing, creating a dynamic chunk, not in the same bundle. So I'm lazy importing the dashboard, the editor, the website, and I'm writing like a very simple router that says, okay, if my path is dashboard, present the dashboard, otherwise present the editor, otherwise present the website, and everything is nice. And it looks like that, right? So the browser goes, the user goes into like this entry point, and this entry point, depending on the screen, it bundles, it creates a chunk depending on the entry point. But what happens if we have shared dependencies, like you can see here, that the main site and the editor are sharing a dependency, and maybe the dashboard and the editor are sharing a dependency. So what Webpack will do is it will create a chunk for this dependency, and this dependency, this chunk will be loaded whenever the main chunks are loaded. So just imagine if I have, for example, if I have the editor that's requiring different dependency, I might get more code than I need just because Webpack bundled them into separate chunks. Okay, so we don't have control on that. And that's basically the benefits and gotchas of dynamic chunks. So the benefits of a dynamic chunk approach is that you have a single entry point and you don't need orchestration because Webpack does it for you behind the scenes, and there is no code duplication. Webpack makes sure that there are no duplicate code in the same screen. It just bundles it into one bundle. But the gotcha is that you have very little influence on chunking, and you cannot do partial builds. You cannot say, okay, I want to build only the editor or only the dashboard. You have to build everything and let Webpack bundle and create dynamic chunks for everything. Okay. The next thing that we can do is create multiple entry points. And in multiple entry points, we mean that instead of having just one entry point, app.js, that generate chunk, and those chunk bring their own dependencies, we can actually tell Webpack very easily in the configuration, I have multiple entry points. I am declaring, as a programmer, I'm declaring that editor is an entry point which is different from the dashboard and different from the website. I don't want to have like a router or something because I want you to bundle it differently. So that they can still share chunks, and they will still share chunks, but Webpack will create from those entry points different bundles altogether. So it will create editor.js and dashboard.js and website.js, and there will be different bundles. So these entry points, okay, so the entry points inside dashboard or inside editor, inside website, will create, and all of their imports, all of the dependencies, of course, will create those bundles. So dashboard/index will create dashboard.js, and editor will create editor.js, and website.js. Okay, so you have this is our way to tell Webpack those are different endpoints. But the problem here is now we need to orchestrate it. Okay, so Webpack tells us, okay, these are different entry points. That's okay with me. I will create different bundles, but it's on you, it's on us to import those entry points, import those files wherever we need. So now we need to go to dashboard HTML and import the dashboard.js, and we need to go to editor and import the editor, and we need to go to website and import the website. So now we need to do this sort of orchestration of knowing where to put each one of them. Okay, so we have more freedom, but with great freedom, with great powers come great responsibility. So now we need to orchestrate it. But we don't have to stop there, right? We just saw a single Webpack process that creates multiple endpoints, and we don't really need to stop there. We can have multiple Webpacks, and with multiple Webpacks, that can be really cool because now if I have multiple Webpack config, I can just run them separately. And now we're starting to get into something which is more the modern approach, but we need to understand the caveats in that. Okay, so let's see what happens here. When I run separately the build website, build editor, build dashboard, I spawn different Webpack processes that look at different configs, and each of them bundles their own dependencies, right? So maybe all of them bundle React and some of them bundle Mobix, and those dependencies are not shared. They're not shared because those are different Webpack processes as opposed to a single process that has multiple entry points. So now we can achieve full isolation. In our dist folder, we would have different different dist file for dashboard, for editor, for website. Okay, so it's full isolation. It's as if this code is at different places. Okay, so we gain full control over the build, right? Because we can tell, okay, I want to build only the dashboard, I want to build only the editor, I want to build only the website. So we gain this benefit, and we can actually have them in the same repo and use the same, even in the same npm package. We can use the same npm package with the same dependencies, and we can do incremental deploys, meaning that I will build the editor only if something in the editor code changed. Okay, I can't do that if I'm doing split points. I can do that if I'm doing multiple webpacks. But the new problem that we now have is first of all code duplication, because every bundle bundles its own dependencies, and it still needs orchestration. Now it needs even deeper orchestration. So what we're doing, for example, is we have a file that's calling modules manager, and the modules manager basically says that if in the code I want to load some bundle, that now the bundle is totally separate, I need to do it in the code. Webpack doesn't know that I have different bundles because we're doing different separate webpacks. Now I need to write something like get module async, that given the name of the module or the name of the bundle, it knows to bring me, here we're doing a require AMD, but it knows to bring me the file, and only then I can use it. Okay, so again, we gained a lot of freedom by telling Webpack, okay, just build it for us, but don't orchestrate, but now we need to do this orchestration. Okay, so for example, what I would do is I would do get module async editor, and then the modules manager would go and search for the editor.js and brings me back the API or whatever it exposes, and then I can use it. And the same thing with dashboard. I'm doing get modules async dashboard, and then I can use it. Again, whatever we did before with the dynamic import, now we have to write it. We have to write this utility function. And the nice thing is that we can just throw everything on CDN or S3, and it will take care of everything for us. But again, we have code duplication, right? Because, for example, let's say that for the Avengers, these are the Avengers, and we want to bundle all of them. And for Guardians of the Galaxy, these are the Guardians of the Galaxy, and we want to bundle all of them. And note that Thor is both in the Avengers and Guardians of the Galaxy. And for WandaVision, this is WandaVision, and we want to bundle all of them. So if we bundle them in different bundles, we would see that we have some sort of duplication, and those duplication will be bundled in every bundle. So Thor will be bundled twice, and Vision and Wanda will be bundled twice. And in order to avoid it, we can use a very useful tool in Webpack that's called externals. Externals is basically telling Webpack, hey, I have those dependencies, and I'm in charge of putting them. I'm in charge of putting them on the window. You don't have to bundle them. And that's a very good tool when you have duplicate dependencies. So, for example, if we have the Avengers and the Guardians of the Galaxy, and both of them want Thor, we can just provide Thor as an external. Okay, like you see here, we can provide Thor as an external. We're in charge of putting it on the window, and then it doesn't have to be bundled. But we have to enforce separation if we want to build those incrementally. If we want to the ability, if they're in the same repo, and we want the ability to say, hey, I want to build just editor or just dashboard, we have to enforce this separation, and we can do it via ESLint plugin. There are a lot of them that says if you're in the editor directory, you can't import from the dashboard directory, for example, because then we won't be able to know if something changed in the dashboard that we want to build the editor as well. Okay, so this is enforcing separation. This is how it works with multiple webpacks. So we have the editor here, and you can see like an image picker in the middle. And then we have the dashboard, and we also have an image picker. So image picker is a separate webpack, a separate code, a separate config, and this image picker is being built separately, and then it can be used in the editor. And this is how we do it. You just like open a pop-up in the editor and say get module async image picker, and you just render it into the pop-up. Okay, so this is how it looks. The modern approach now is micro frontends. Micro frontends basically mean you assemble an app from independent parts. They don't have to sit on the same repo. They can be in different repos, in different technologies, like the ISS is the International Space Station was being assembled back then. And micro frontends is what allows you to build an app with different technologies, with different worlds. Like Netflix is hosting different areas of sci-fi, then you can do it like that. And basically it means, okay, I have this view, I have this app in front of me, I can just look at it, and just by looking at it, I can break it into different parts, and every one of those parts can be built and deployed independently, right? I don't have to have this connection between them. I can even host them in different places. I can sound them in GitHub, sound them in GitLab, host different repos. I can use different technologies, Angular, Web Components, React, even Svelte, and eventually everything that I build have to be connected together into the same app. So the user faces the same app. They face the same experience, but this experience is actually being created with different bundles or different build product, different assets that are being built independently. So what it means that you have different repos, so you can separate the build and deploys, which is amazing. This is exactly what you want to do when your application becomes a little bit complex. You want every team or every person to be able to build and deploy independently from the rest of the app. You have full autonomy for every repo for you to use which technology they want, but you have to take care of orchestration. So orchestration, as you can see, as the level of freedom goes up, the need for orchestration goes up, because the tools that we're trying to shake off now, those are the tools that provided us this orchestration. So Webpack and single repo and everything, we're trying to shake them off now, but we need to provide this orchestration. And you can use and you should use packages for dependency management. And basically, you have to leverage externals or external dependencies because you're going to have a lot of different repos that use the same dependencies, and they have no way of knowing on each other. So if you have the editor and the dashboard and the website, and you have like a UI components that require some sort of npm package, and all of them need React, you can't bundle React in all of them, because that way on the same screen you would have four bundled versions of React. So you have to leverage external dependencies if you're using micro frontends. And it also, there are a lot of questions there. It requires versioning. For example, if I'm micro frontend, which version am I using? It requires discoverability, composition, and we have frameworks that can do that, or we have solutions that can do that. You can use just custom JS code like we saw. You can use frameworks like Single SPA. Even iframes is a good solution for micro frontends, or server size includes. So basically problem solved, right? We can maybe finish the presentation and that's it, but not really, because now you have a lot of teams working in a lot of repos, building a lot of packages, and you have to take care of all of them. And what happens if one of them change? How do you know? How do you update the version in all of the others? So micro frontend poses a lot of problems that you have to look into to understand. But then we have monorepo to the rescue. So it all depends on how we look at it. We can do different packages, but we don't have to be in different repos. We can put them on the same repo, so they can use code and use common dependencies and know of each other. But so being in the same repo, but still produce different packages, so we gain the composability and we gain all the benefits of micro frontends. And we have, for example, Lerna is a really good way, a really good library to tackle it. I urge all of you to look into it. Lerna, we have others as well. But it all comes down to the question of separation versus duplication, right? So we want to separate everything, but we don't want to duplicate the dependencies. So that's something that always have to be on your mind. Today we have Webpack Module Federation in Webpack 5. I will say a few words on it. So in Module Federation, Webpack basically tells us, hey, I can solve this problem for you. Use me as Webpack, but I will make sure that the dependencies are not duplicated. So for example, let's say I have app 1, and that's like the host, and I have app 2, which is inside app 1, and both of them are using button, the green button. And app 1 doesn't want to bundle the button on its own. It wants to consume the button from app 2, right? So it can tell Webpack, app 1 can tell that, hey, I'm app 1, app 2 is the remote for me, okay? So me as app 1, I'm declaring app 2 as a remote, and I can share React and React DOM with it. And app 2 can say, hey, I'm app 2, I can expose button. Okay, so app 2 basically means tells Webpack, I'm including button in my code, the code of button, and I'm ready to expose it to whoever wants to use it. Okay, and that's really cool, because then I can in app 1 I can just import app2/button, and Webpack is smart enough not to bundle the button in the app 1 code, but use it from app 2, because it knows that app 2 is going to expose it. So it's really cool, and app 2 can use button how it likes. Okay, so it's really nice, and you can create much more complex things with it. You can have apps that are requiring both lib app that exposes React and React DOM, and also component app that expose all the components, and all of them will be bundled separately.
Hey,
Instead of,
Liat.
yeah,
Hey, thank you. Unfortunately, we run out of time a little bit. So if you please just tell few last words about the presentation, because we have a lot of questions,
sure.
and I would love to ask few of them. Sorry, but
So we're running.
time is
Okay, so
time.
that's the final slides. Yeah.
Thank you.
So basically, okay. So model federation of Webpack is super interesting. I won't go over it, but just it's magic. So read on it, and we have a lot more other solutions. But my point is, we don't have to see code separation and duplicate dependencies as rivals. We can have them joined, and we have good tools today, and we just need to use them. And now is the time for questions. I hope you enjoyed the presentation, and thank you.
Thank you, Liat. It was awesome. To me personally, I love topics of micro front ends, modularization, creating, a lot of possibilities to optimize our front end apps. So it was amazing. Very big portion of knowledge and experience. Thank you for that. So let me pick some questions because we've got tons of them. So yeah. So for the first question. Okay, so let me grab this one. Can we share a global state data among different packages through monorepo in micro frontend?
Yeah, so that's a really good question. And basically, when you work in a micro front-end architecture, the question of global state is something that you need to tackle. There are several solutions. What you can do or what you should do is just remember that all of those micro frontends are running on the same window, right? So for the browser, it doesn't care. The browser itself doesn't care if you're bringing the code from a micro frontend or you bring it in dynamic chunk. So if you have the host application that is actually hosting all of these micro frontends, also holding a global state, it can expose it to the micro frontend via API, via an agreed upon API, and then those parts can actually collaborate on that state. And we're using Mobix, which is very convenient for that sort of issue. But even if you use Redux, you can merge reducers, right, with Redux. So every micro frontend can add its own reducers to the global state. So basically, global state, just remember it's the same window. All of them are working on the same window. And if the host app is exposing the global state to the micro frontend, you can actually use it seamlessly between the micro frontends.
Mm-hmm. That totally makes sense. Thank you for the answer. Another question. Should we define lazy loading in all the components, or root component is enough?
Yeah, so it's also a good question. That should be according to your needs. If you have very small screens, like very simple screens, then you can do it in the router, and that will be enough. But if you have complex screens, like you have like a very complex app, then you might want to define lazy loading for other parts in your application, which are not related to the router. But for example, you don't want to open them until someone does some sort of a click. For example, my example of an image picker, that someone clicks something and then the image picker is being opened, you don't have to bundle the image picker code in the main app code. You can do a lazy loading of it and then have a dynamic chunk just waiting on the lines, waiting for someone to click the button. Only then it will be loaded. So it's according to the need. I wouldn't try to optimize it from the beginning. So first of all, just write it as you want. Webpack has great defaults in regarding to dynamic chunks. But if you run into problems, if you see that your bundles are being too big, if you see that the loading time is being too large, then it might be a good idea to define some dynamic, some lazy loading and dynamic chunks in your code.
Thank you. Great answer. I also agree on that. If we start using all the optimization tools from the beginning, what we are going to use at the end of development, how to optimize it, if we use all of them. Cool. Another question. I have used micro frontend architecture recently using single SPA. Will code splitting with lazy import still work with that?
Yeah, so it's actually a good question because we haven't used SSPA, so single SPA. I would imagine that lazy and import would work because they're part of React. They're not part of your framework, like the SPA framework, but they're actually part of React itself. So they should work. They're the core part of React. You can easily try it and see if it works. I would say it should definitely work.
Cool, thanks. And very last question. Unfortunately, we won't be able to ask all of them. So, guys, if you want to reach Liat, just check his socials and yeah, let's get in touch with Liat. So the last question, it's also interesting for me. Could you recommend any books, resources on architecting micro front-end applications?
Oh, yeah, that's actually it's a good question because it's such a new field. There are not a lot of resources on it, but I would go into a Bit SRC blog because they write a lot about micro frontends, and also Wix have a very amazing write-up about how they do micro frontends. It's I think like 35 minutes read by their head of front-end engineering. So there's a blog post in Wix blog, and I would say yeah, basically BitSRC and maybe Wix, maybe um, Vite is a tool that's starting to be used in that kind of architecture. So they have good resources on it. But it's a new field. So I would imagine that in the coming year, there will be more and more resources and maybe some sort of a de facto standard of how to do micro frontends. As you can see now, everyone does their own and run into the same problems and invent the same solutions. But I would definitely stay observant on the field, and I would imagine there will be much more resources coming on.
Yep, totally agree. Thank you, Liat. That was all of the questions. So thank you for the presentation. Thank you for being a speaker at React Global Summit. It was really amazing topic, and hopefully see you next time.
Yes, have a great summit. Enjoy, everyone. Thank you very much.